Lesson 10, Distribution Table, Example 2. 12 residents from the city of Rockland were randomly selected and asked, how many TVs are in your household? The following data were obtained: 2, 3, 3, 1, 2, 5, 3, 4, 1, 2, 4, and 3. Construct a frequency distribution table with this data and describe the result. Well, here we're asked to construct a frequency distribution table. That is, we need to make a distribution table which displays the data alongside the frequency statistic. After we've completed our distribution table, we then need to describe the result. Now, the first thing to consider whenever we're making any sort of graph is to come up with a descriptive title. Titles need to communicate the data and the population from which the sample was collected. In this problem, the data were the number of TVs, and the population where the sample was collected from was Rockland households. So a descriptive title for this type of data would be the number of TVs in Rockland households. Now, to construct the actual distribution table, we draw a rectangle which is divided up into rows and columns. Now, each of the columns need to be clearly labeled. The first column in a distribution table is labeled for the data. In this case, the data was number of TVs. The next column is the statistic column. And in this problem, we are specifically asked to construct a frequency distribution table. So now, to complete the data column for number of TVs, we need to look at the actual data. So here is the sample data. And this raw data was the result of a random sample. And so the raw data is in random order. The whole point of making a distribution table is to organize and display the data in a fashion that is easy to read and understand. So we need to take the time to organize or sort the data first. So to sort this number of TVs, we first need to look at the minimum data value. In this case, the minimum number of TVs in a household in the sample was 1. And then we need to look at the maximum data value. In this case, the most number of TVs in any household was 5. So we can list the data in order from the minimum data value, 1 TV, all the way to the maximum data value, which was 5 TVs. So now we can find the frequencies, starting with the 1 TV households. The frequency is determined by counting. So now we must go through our sample data and count all the households which had 1 TV in them. So going through the data we count, we find that there was 1, 2. A total of 2 households contained just 1 TV. So the frequency of 1 TV households was 2. Now, to find the frequency of households that contain 2 TVs, we go through all the data and count the number of 2 TV households. So here we found that there were 1, 2, 3 2 TV households, giving the frequency for the number of 2 TV households of 3. Now, the frequency of 3 TV households, we find this by counting the number of 3 TV households in the sample. Here we find there's 1, 2, 3, 4. A total of 4 households in the sample contained 3 TVs. So the frequency of 3 TV households was 4. Now, for 4 TV households, we find there are 1, 2 households in the sample that contain 4 TVs. Therefore, the frequency of 4 TV households is 2. And finally, 5 TV households, there was only 1 in the sample. So the frequency of 5 TV households in the sample is 1. So here's our completed frequency distribution table for the number of TVs in Rockland households. As a check, if you were to sum up all the frequencies, you would get the total sample size. In this case, the frequencies do indeed add up to 12, the total sample size for number of households in this sample. Now we're ready to describe the results. To describe the results, we need to report, in words of the problem, results that can be directly derived from the data. So looking at our frequency distribution table, we could see that the highest frequency of 4 corresponded to 3 TV households. So there were more 3 TV households than any other in this sample. But this was closely followed by a frequency of 3, which is associated with 2 TV households. So 2 TV households were the next most represented. Next, there was a tie. There was 2 households each containing 1 TV and 4 TVs. And finally, 5 TV households, their frequency is just 1. So putting this all together in words of the problem, we can find this description. Most, which was 4, of the 12 Rockland households sampled had 3 TVs. This was closely followed by 3 other households which had 2 TVs each. Next, there was an equal number with frequency of 2 of 1 and 4 TV households. Finally, just 1 household reported to have 5 TVs. This description, although accurate, was not expressed very clearly and seemed somewhat convoluted. The objective in descriptive statistics is to organize and present data in an accurate, useful, and informative manner. Data that reaches the ordinal level or above can be further examined to identify particular patterns in the distribution. In this sample, the highest frequency occurs in the center of the distribution. As the data values move away from the center, both before and after, the frequencies decline in a symmetric fashion. In statistics, this type of pattern exhibited in data is referred to as bell-shaped. This pattern gets its name bell-shaped from the shape that a bell gives. That is, the high point is in the middle or center, and the low points are at the ends, both below and above the center. And the pattern that it makes is symmetrical, both below and above the center. So data that takes on this pattern, high in the middle, low on the ends, and symmetric, that is both the shape it appears off to the left of center and to the right of the center, is about the same. So we can restate our description the following way. For this sample, the number of TVs in Rockland households resembled a bell-shaped distribution. Learning and understanding the language of statistics allows us to make clear, concise, and constructive descriptions.